Hi, in this presentation, we begin to examine the content of Chapter 2 and go over the learning objectives of this chapter. So I'd like to do that first. I'm going to be sharing with you the learning objectives for this particular aspect of the course. In Chapter 2, we're going to learn about specialization and exchange. In particular, we're going to be, at the end of this chapter, able to do these 5 things that are listed in the slide. One is how to build something called a production possibilities frontier. So we have to do that first. Second, we're going to then use this model, this visual graphic model, to learn about what particular factors cause changes in production possibilities frontiers. So when it says here what causes shifts in production possibilities frontier, we're going to study the factors that go into affecting and changing our production possibilities curves or production possibilities frontiers. Third, we're going to use this tool, this graphical tool, to build a model, and this model is going to explain 2 concepts about exchange. One is the notion of absolute advantage, and the other one is the notion of comparative advantage. And by doing so, by using this model to try to understand what we mean by absolute advantage in exchange and comparative advantage in exchange, we will be able to explain why people or companies specialize in certain products, services, or activities, economic activities. And last but not least, we're going to see how this specialization arises from comparative advantage and not from absolute advantage. And we will try to gauge the importance of that. So these are the 5 goals that will lead us to understand specialization and exchange in economics. So let's start. We are going to start with the definition of 2 tools. Well, 1 tool, the production possibilities frontier. And we're going to use a specific characteristic of the production possibilities frontier in order to begin to understand specialization and exchange. Again, let's remember what our goals are. Our goals are to understand specialization and exchange. And to do so requires that we first learn how to build, construct production possibilities frontiers. We're going to need to know what causes changes in production possibilities frontiers. And then we're going to learn about a notion called absolute and comparative advantage. We're going to try to explain why people specialize. And last but not least, we're going to understand how specialization arises from comparative advantages, or the comparative advantage in the production of goods. So these are our learning objectives for this chapter. So what is a production possibilities frontier? In this particular very busy slide that you see here, the production possibilities frontier is this red line here. It's this red line that has a negative slope. The way we use production possibilities frontiers is as a way to describe two things. One, scarcity, and the other is the opportunity cost of one item versus another. Okay, so in this case, imagine we are trying to understand the productive endeavor that we go through in a particular day of work. And in a particular day of work, we might be solving math problems, or we might be writing paragraphs for a report of some sort. And we only have a limited amount of time during the day to do these two activities. And that allocation of time allows us to solve as many as 20 math problems, or as few as 0 math problems. And when we use all of our time to solve just math problems and none of the time to write paragraphs, we can achieve a productivity of 20 solved math problems. And to contrast that, if we devoted all our energies and time allocated to writing paragraphs, we could write 6 paragraphs. And in that situation, the output would be 0 math problems. So we're going to call those 2 points in this Cartesian plane, in this XY plane, points A and point G. Point A is the point that has 0 written paragraphs with 20 math problems, and point G is the problem, the point on the other extreme of the Cartesian plane, where we devote all our time to the production of written paragraphs. So that is the production possibilities frontier. What does that line visually help us understand? It helps us understand the collection of all time allocations that we can feasibly devote to writing paragraphs and solving math problems in tandems, in combinations of the two, rather than just one or the other. So rather than looking at the extremes, which are labeled here as A and G, we are looking at points like B, C, and D, which are points in which we use some or all of our allocated time in a manner that is attainable. So we're going to call the attainable data points those points that fall inside of the production possibilities frontier, inside of the red line, in the green zone. And then the points like E and F, which are beyond the red line, colored here in brown, are points that are unattainable. And in those points, we just don't have enough time in the day to actually achieve levels of production that can give us points like the question mark points E and F. So that's one of the uses of the tool, the production possibilities frontier. We know from the production possibilities frontier what is feasible, what is attainable, what is within our resource set, and what goes beyond our resource set, what scarcity prevents us from attaining. The brown zone is that latter zone. The second thing that this red line enables us to observe and to see is that is actually based on the slope of that line. You notice how I drew the line with a heavy tilt in favor of math problems. So here we're looking at a person with this red line is describing a person who's more mathematically inclined and less able to write well in English or write effectively. So this person is good at math and not so good at English, so to speak, or at writing. And the person we're modeling here. And so the slope of that line is an indication of the trade-offs that that person would have to undergo in order to either achieve more math or more English. You can't have both because you don't have enough resources to go beyond the red line. And so in this case, to go, say, from point A to point B right on the production possibilities frontier itself, means that you are foregoing doing some of the math, solving some math problems, and in exchange for foregoing some of the math problems, So we're moving down from 0.020. Okay, so that's actually foregoing some math problems. And in exchange for that, we gain time, resources, that would help us move toward point B. And so that particular amount of time then enables us to write some paragraphs, get a little bit of both done, be at point B. And at point B, we do some math and we get some English done, a little bit of both. So the question then becomes, at what rate are we trading off? Are we exchanging math for written paragraphs? And because the production possibilities frontier in this case is a straight line, it forms, along with the x and y axis, you see a triangle here. Triangle, I'm going to call this triangle AOG. The green triangle is at the top apex is A, at the origin it's O, and at the far right point is G, AOG. So in this triangle here, the rate of exchange of math for English is the same. And by similar triangles, therefore, I could go from a height of 20 down to a height of 0, meaning I can forego as much as 20 different problems of math solved. And if I give doing that up, I get enough time to write 6 paragraphs. So what I give up is 20 math problems solved, and what I get in return is 6 written paragraphs. So that's how we have a measurement of the opportunity cost, what I give up for what I get. So when I divide the minus 20 over the plus 6, I get a minus 3.33. And what that number represents is the opportunity cost of a written paragraph. One written paragraph is worth 3.33 solved math problems. And likewise, the opportunity cost of one solved math problem would be the reciprocal of that, 1/3 of a word problem, or of a written paragraph, sorry. Okay, so that is what the production possibilities frontier enables us to do. It enables us to A, graph or visualize the notion of scarcity so that we know what's attainable and what isn't. And in doing so, the borderline between what is attainable and what isn't provides us with an algebraic device that enables us to measure trade-off by measuring the rate of the slope of that trade-off as we go from one extreme, point A, to the other, point G. So that's how we construct a production possibilities frontier. It is a graph that helps us understand our resource utilization, our scarcity based on the resources we have available, and how that scarcity plays on the opportunity cost of what we give up for what we get. Second point, what causes shifts in the production possibilities frontier? Well, what causes a shift in the production possibilities frontier are one of two things. When we have a production possibilities frontier, we usually graph, again, one use of a resource versus another. So as we learned in algebra, we call the horizontal axis X and the vertical axis Y. So in this case, X is going to represent something we want, and Y is going to represent a competing interest of ours. So both X and Y are wants, and the production possibilities frontier is going to represent the limitations of our resource utilization in obtaining X and Y. And just like before, I'm going to call this upper point here A. I'm going to call this lower point here G, and I'm going to call this origin point O. Triangle AOG. And we're going to visually represent the points of feasibility in green. So these are the so-called attainable points, or allocations of our resources that allow us that are attainable, that we can actually get thanks to the fact that we have the resources to get them. So these are all attainable resources. These are all good. And points that are beyond that red line are points that are not attainable. Can't get them. Okay. Well, what would make it possible for us to attain more than AOG? The answer is that if we were able to obtain more productive resources, then we could use those resources in satisfying a greater amount of X or Y or both. So how do we graph more resources? The answer is we do so as an expansion of the red line. We do so as a shift of the PPF, a shift of the production possibilities frontier. So word up or right in the manner in that direction. Okay. So more resources would imply that the red line that we see here would essentially expand outward like that, in that direction. So I'm going to draw another production possibilities frontier with a higher level of resource as a pink line here that goes, instead of going from A to G, the line's going to go to H and K. And that would imply that we now have more resources available than before. So we have greater abundance. So this blue zone is by how much our resources become expanded. So that's what we mean by more resources in blue. So we would end up with a pink and not a red production possibilities frontier. From an initial of red to pink. So I hope that makes sense, that one of the things that makes for an expansion of productivity in an economy, or an expansion of consumption, or of uh, attainability of greater benefit in an economy, is more resources. Okay, so this picture shows that more resources means more attainability of benefits or goods production. Or back in the earlier example, if we had more time to devote, we could do more math problems, and we could also do more English, or we could do a little bit more of both. And this would be how you would reflect that image as a shift, a parallel shift of the production possibilities to the right or up. And it's key, the word parallel is really important there. Okay, so the pink line and the red line have to be parallel to each other. Okay. So more resources, more benefits, and no alteration of the terms of trade. So it's also important to know that there is no alteration to the opportunity costs, the terms of trade, the terms of exchange between X and Y. That's very important, that an expansion in overall resources doesn't alter the rate of what we give up for what we get. Now, what happens when we one day go to class and we learn something in our English class that makes us better able to write, but not necessarily better able to do math? So that is called technological innovation. So what technological innovation sometimes does is it alters the opportunity cost of two competing interests or alternative. And the way we show that off in the PPF is the PPF expands outwardly with a change in the slope of the PPF. So the terms of trade between one activity and the other are impacted by that. So let me begin with a pair of axes. We have the horizontal and vertical axes here. In this case, we're going to call the vertical good y and the horizontal good x, and we're going to have a starting point, which is going to be a system where x is a lot easier to do than y, so you can do a lot more y for x. It's sort of like the story if you're good at math but not too good at writing, and you end up with something like this. So in that situation, you might remember we call this point A. Point A allowed you to solve 20 math problems while doing no English. And point G allowed you to do 6 paragraphs if you didn't do any math. So then comes the innovation. The innovation is going to be in blue. And the innovation is that at some point you learn something about writing. You learn a writing technique, or you learn a writing exercise, or you learn to make your brain function in a more productive manner with respect to the written language. And at some point you learn something about writing, about X, that makes you a more productive writer, prolific writer. You become a better writer without necessarily implying that you become better at math. So now, were you to devote all your energies writing, you would produce more writing than before. So instead of 6, you'd go to 10, say. 10 written paragraphs. How do we signal that? How do we signal that particular effect graphically? So that particular effect would result in point G moving to a new point. So we're going to call that not point G. We're going to call that point G prime. New point G. And what's going to happen is that's going to make the production possibilities frontier still stuck at 0, 20 up on the vertical axis, because you're not becoming better at math if you're just doing math, but you're becoming better at English. And so what that creates is an expansion that augments your possibilities. Except the possibilities are not augmented both ways proportionately, but rather disproportionately favoring English, which means that the opportunity cost of English has gone down. Now you can give up fewer solved math problems to get more written paragraphs. So you don't need to give up math problems at a rate of 3.33 to 1. So the opportunity costs change from from 3.33 math problems per 1x. So you have to forego, you used to have to forego along AG, along production possibility frontier AG. Now, it's 20 down, 10 to the right 2 for 1. So now you have to give up 2 math problems or 2 units of y per gain in x along the PPF called AG prime, which is the production possibilities frontier after the disruptive technological innovation occurs. One of the nice things about a production possibilities frontier is that it can visually explain economic growth. It can visually explain expanded resource base. It can explain what happens when scarcity diminishes, and the opposite as well. If scarcity augments, the production possibilities frontier curve shifts to the left and down, and it makes the feasible set of attainable points smaller in that situation. And so notice how technological innovation, or how changes in the opportunity costs, affect the slope of the production possibilities frontier, whereas an expansion of the resource base creates a shift of the production possibilities frontier. In our next video, what I'm going to be doing is I'm going to be covering the next topic, which is about comparative advantage and absolute advantage. And we're going to use 2 tools to describe that. One is going to be a production possibilities frontier, and the other is going to be a table, a production schedule table. So we're going to be able to see that and to do that. And then we'll also look at how it is in this tilting of the production possibilities frontier through innovation, or through differences in opportunity cost, that we are able to then explain why people tend to specialize into different kinds of activities in their lives. You know, why math people do math, and why English people write essays and poems and contracts and things like that. And I hope that so far that this was a useful video, and I hope that you get a lot out of watching it.